Hi everyone, I am UTI. Welcome to my channel, and today I'm going to just demonstrate a very easy and a very simple network security attack, which is known as TCP Syn Flood. It is a kind of a DDoS attack, which is just is about flooding sync packets to the victim, to the target, and it in a way, you know, denies service in such a way that the victim is not allowed to connect to any other, user or computer that it should have in a normal scenario. So explaining what it does is, like, for example, this is basically a three-way handshake. Just a second. So I'll use image. Use this. This is a three-way handshake, and what it does is that, for example, you've got two users, A and B, which are to connect. So what it does is that A will share. I hope my screen's visible. Yeah. So what it does is that A will send a TCP sync packet to B, and then it will also have a sequence which is the ISN. Now ISN is a completely random number, which is also the initial sequence number. It can be random, and along with it, an acknowledgement, which is ACK. Obviously, it's zero. Then what B does, it will send a sync ACK packet with the initial sequence number of B and an acknowledgement of +1. Then it'll send an ACK packet with a sequence A+1 and an ACK B+1. This A+1 and B+1 will be happening in the first part, in the first instance, when they are, to connect, there is a three-way handshake happening. Once the three-way handshake is successful, the sync would be as same. I mean, it won't change to +1 or to +10, not necessarily. So that is the base of a three-way handshake. Now, what happens in a sync flood is that, like, let me show you. For example, this is a user. Let's name him H, and there is another user. Let's just copy paste. And what the hell is happening? Just a second. There is uh, Control C. Yeah, it happened. Yeah, it worked. So I don't know what happened for a second. So, for example, it sends to what's this? It sends to H, but what happens is that you've got an intruder. We'll go with I. What it does is, instead of, you know, what it'll do is that it'll send a ton of it will send around 100,000 sync packets. Instead of H sending it to Z, I will be sending it to Z, simultaneously. And what will happen is, now what happens is actually, uh, the the connection, the port which opens at Z, also takes some memory and some CPU, and then it takes some space basically. So when you know in a just a second you just send around 100,000 packets, the user, the PC Z, won't be able to accommodate that amount of information in such a small period. So what it does is it just, you know, disconnects, and you basically just try sending another, you know, the whole information to a random IP. So that what switch happens, and So yeah, basically that is the crux of it. When you go a little deeper, it is in a way that in a normal three-way handshake, the port a user can take about 50 to 100 ports in in I mean not ports as in but yeah connections in one go, and then in when this happens, it'll during a flood attack it'll just exhaust very quickly because the TCP sync is around 40 bytes, and it is quite impossible to accommodate 100,000 sync packets at a time. So a very good mitigation to this is a sync cookie. Now what it does is, you know, A to B, they'll connect, and A will send a sync cookie as well. Now I'll just add it here, sync cookie. Now what happens is then A will send the sync cookie again as an act, sync cookie, and B will match those sync cookies. It won't store it, it will just generate it again and will match those sync cookies. And if they match, the connection is established. So for example, just to elaborate a little more, B sends it to A with a sync cookie, which is basically an MD5 of a lot of things like source, the destination IP, the port, the time, or a secret number as well. So it's a MD5. Now MD5, you may say that the MD5 is around 128 bits, but then sync cookie is just 32 bits. It basically takes the first 32 bits of the MD5 hash. So what happens is that B will just send it to A, and then A will send it to B. Now B doesn't store the sync cookie because it also takes space. To avoid the utilization of space, it will just regenerate the cookie and just match the cookie. If the cookie matches, then the connection is successful. So it's as simple as that because yeah, it's just as simple as that. So, but you may ask then why we don't do it, we just why do sync floods still happen, still persist if we have got a mitigation strategy? The thing is, sync cookie also take up space. They if they don't just take spaces, but they also take time. For example, in a normal circumstance, if a user B connects to, say, user A and handles around 100 connections when the sync cookie is off, it'll take around 50% of the space. For example, in a normal, uh, yeah, if 100 there, then around 50. I mean, basically, it'll reduce the utilization to 50%, which is a lot to be, you know, there in all use cases. So by default, the sync cookies are set to be 0, and if anyone wants, they can just turn it on. So, uh, sorry, there was some notification. Just a sec. Yeah. Yeah. So that is the sync flood. Now I've already installed the seed labs in the VM. You can do that. You can just simply go to seed the seed project. You can talk about TCP labs. This is you can go here as well just to get a bit of more information. You can download this. If you are in a Mac PC, you download the ARM. If you're not, just the zip file is good to go. So I did that. I just show you, that one. And that's the zip file I set up. I so if you go, the best part is that you'll get a this is the seed VM basically, so it automatically opens the seed security labs. If you go to the lab part, you go to 2.0, which is the recent one, network security. You've got TCP attack labs. You actually get a very good PDF that where you can talk about sync floods, attacks and sync cookies. So it also talks about the lab environment. You've got attacker A, B, and C host. So and you've got some acronyms as well, which can be used instead of the whole command. Like for example, Docker compose build can be just DC build. So that makes life a lot easier. Yeah. So you've got a lot of things you can read about. Then the first task, which I'm going to show you in this video, is a sync flooding attack, which is obviously attack of DDoS attack. It is, in order to, but the attacker have no intentions to finish the three-way handshake, instead uses spoofed IP and how to proceed. So it just happens. You can just, it's a beautiful, quite good image of what happens between the client and server. And then, as I mentioned earlier, they all go to a random IP. So yeah, basically the three-way handshake is disrupted. So though I mean, it's a very good, I would say, a walkthrough with commands. Though I remember quite keen of them, but still, yeah, I'll keep that as a reference if at all I miss something. So initially, I'll do DC build, though everything is still built obviously in my uh, system. So it's skipping everything. Now go to DC up, which is the Docker Compose up. We'll see that it's happening. They are all up. And then we'll go to uh, the doc ps, and we'll get to know the IDs. So if you don't know what doc ps is, we've got everything up here. We've got all sorts of alias for doc ps. You've got, so basically instead of docker ps format and IDs and names, you could just use doc ps to get to know you know what IPs are there. I mean, what IDs are there, not IPs, what IDs are there, and their names as well. And doc sh is basically to execute and to, in a way, connect, and in a way, just play for the attacker. Like for example, you doc sh to the attacker ID, which I'll do right now. Just a second. I'll do it right here. If I go doc sh and I go seed attacker, I'll take the role of an attacker. If I go doc sh and if I go user one, you know, 10.9.0.6, I'll take the role of the user. And then if I go to the victim, I'll just doc sh 10.9.0.5, and of course forgot the victim there, the ID. So I take the role. Now, if you don't know, if you're thinking how I'm getting this, then here's the clue. And also you have another clue, which is this. So yeah, basically. And then now the other thing, what since this is the attacker part, we know that the volumes folder in the attacker Docker is shared, which is also written over here. So basically, you can also just open the compose file and get to know the four roles actually: A, B, the user one and user two, the victim, and the attackers. You've got the attacker, you've got the image, the the container, TTY, if it's privileged or not. By privileged, I mean if it's true, like for example, the victim is privileged, so you can just edit the sync cookies part as well. For example, that's an actually very good example. Like I'll give another example. The sync cookies. If you ever try to turn on the sync cookies without privileges, you won't be able to, because it's a read file actually. You won't be able to write it and change it from 0 to 1. But as a victim, you'll be able to do that because the Docker image gives you that, the permission. Similarly, it's privileged over here as well. Now volumes, you've gotten a very shared folder. Similarly, you've got systemctls. See, as in you can see that a sync cookie is by default set to 0. You can change it to 1. And for user, you'll notice that there is no such thing as privileged There's no such parameter as well, parameter only, so you won't be able to change anything. And I think we're good to go to demonstrate the first attack. Yeah. So, attacker mode on, and we just, we'll see if we've got nothing here. And I'll just go to, I'm sorry, I just wrote CD. It should be ls. We've got nothing here. We can go to volumes. Just a second. Dark message, the seed attacker. Yeah, it's fine. It's good to go. This is the one, right? I'll just add one more. I don't know what's happening. Yeah, so ls. We've got an. I don't know why it wasn't working. Probably for some reason it isn't showing ls. I don't know why it should. So I close this, I close this terminal, I just move this to the third one because it's easy to remember. The first two are for setting up the Docker images. The third one is for the seed attacker. The fourth one is the user, and the fifth one is the victim. It's quite easy, and that's what I follow. So if you see that you've got a lot, and you've also got the volumes folder, so you just go to volumes and you'll ls. Now here you'll see a lot of Python code along with a C++ file and an executable, the output of this not C++, sorry, C file. So actually, initially when you download the setup and download, you'll just get the C.C code. You won't get anything else. I've actually solved the lab, the other task as well, so you can see the manual and the automated code, which I'll do in the next videos. But yeah, I mean, that is the only thing which you'll get. And we'll go with the .c only. I'll show you how you run the .c and do the Syn Flood Attack. So pretty easy. And if you want to just, if you want to do the for compiling the .c, you go gcc the output, Syn Flood, and just Syn Flood.c. So that's the command you'll do. Even you'll get this here as well. If you go down, you'll understand with the commands here also. Just a second. I mean here, right here. It's basically compiling the folder and then running it. So let me go through these commands and all the stuff here. So the thing is, I talked about the cookie countermeasure. It's it's a cookie, and you can just read through it, and you can use this command, for example, to check if the cookie is on or not. So what you'll do is you can just go here, you can see the cookie's on. Cookie is on by default. This cookie, the sync cookie is on, but here in the victim, the sync cookie is not. Now you need to understand one thing is that I'll just show it over here as well. The let's say this is user one and this is the victim. I think the V looks more like a tick, but yeah, you can understand it. So what it is saying is that this has cookie enabled, but this doesn't. So we'll obviously have to attack B, which is the victim. So it becomes B and this becomes A, and we are the intruder. Because the cookie countermeasure is not on, we'll attack this. We cannot attack this because it won't work because it's got the cookie measure updated. Now, one more thing you'll have to understand is that in this version of Seed Labs, the if a connection is made, for example, via telnet between user one and user two, even if you just disconnect and then you try to connect again up and try seed flood attack, then that won't be possible because what happens is that it'll remember the previous connections the machines have made, and it will directly connect. So what am I trying to say is very clearly written over here as well. So it talks about the where it is. Yeah, here it is. The kernel mitigation mechanism on the report 20.04. If a machine X has never made a TCP connection to the victim machine, when the Syn flooding attack is launched, X won't be able to connect. Quite simple, quite easy. But before the attack, if it's already connected, then it seems to be immune because you know it remembers past successful connections and uses this memory to establish a future connection with the returning client. If it just means that, if we go back to this, it means that, just clear it off, it means that if before doing this, if we have done this, then from A to B, then this won't be successful because it is remembering the previous successful connections, and if the same returning machine comes up and tries to connect, it will directly connect, and in a way it is immune to the whole attack. So we'll do that without any problems, and for that what we'll do, we'll just flush all that IP connections. Very easy. So I'll do that in a second. So let us just simply telnet to the victim. The login is seed and the password is D's. It's just opposite. So now, if you see, that's the net, you'll see that one connection has been established. It's a TCP connection. The local address is this. The port is 23. Why is it 23? Because it's a telnet connection. And then the foreign address is the user address, and the port is 576, and it's established. If we just disconnect and then we listen to it again, then we just write this command again, we'll just come across these two because there is just no established connection. Simple as that. So now, just let's just say exit. Probably just log out, and then we go do the same. We'll say a time bit because it's still in that process of disconnecting. But if we go, we say probably so previous successful connections. We'll go show, and it shows okay, this is the previous connection. It was for this much minutes, and other details. What was the source? What was the connection? And similarly, here also you'll see the same thing. The show, and you will see that, oh, okay, so there is a previous successful connection which has been saved, which would make it immune to the attack. So now we don't want that. We really don't want that to happen, that we're attacking but it doesn't work. So what we do is we simply flush. We put it down the drain. And then if we go show, we don't see anything. Yeah, we don't see anything. So the same will be done here. Just flush it off. Again, we go, we don't see a thing. So it's good to go. So now what we do is, we already have the Syn Flood attack. We just need to launch it. We just need to be good to go. So we'll just do it. Again, the port number is 23 because it's a telnet connection. We'll go here. We'll obviously connect initially. Now we'll have a telnet connection. Seed these, and then voila. And we'll get to know in a minute or so that, yeah, something's happening. Something did happen. So you can see that the victim is getting a lot of sync attacks. Yeah? And it will just disappear in a minute. you get to know that a lot of sync attacks are coming, and uh, this would be just lost in a minute or two. You'll just see something like this again closed by for a host. So give it a minute, and it'll work. By the time we can actually see, that if it ever was on cookie 0 or cookie 1. So we again have a command for that, and that command is over here. Just a sec. Yes. Yeah. So this is the same command which we used earlier. It's a systemctl command, and we'll just copy paste it here, and we get to know that the sync cookie is not there at all. So we'll just have to give it a little more time. You're getting a lot of sync flood attacks to the victim side. It'll work in some time. So you'll basically see connection lost as it was earlier by a foreign host. And for that would happen, it will take around 2 minutes. So it would happen. I won't wait for that because it will take 2 minutes extra of this video. Instead of the video is going too long. For a very simple attack, I'll have, that should not be the case. Now, using the same thing with, systemctl, I'll change it. Now, what you can do is you can just simply change it, use this command on the victim side, turn on the sync flood attack, and do the same thing. Go to, once you turn it on, you do IP metrics show and flush. You do this, right? Oh shit. Yeah, you do this. You show and then you flush it off. You do it for victim, you do it for the user, and no need to do it for the attacker. But if you want, you can. If you first you go and see if there's any such connection. If you see, you can. But generally you won't because the connection isn't happening. It's just redirecting the sync packets and the attack packets to a random IP. As shown here. Uh, and it's a random IP, so it won't connect. So you do that IP command, and then you again telnet on the user terminal, and then you do the sync flood attack from the what should I say, the attacker. So since it will take some time to happen, I actually did take some screenshots, which would be quite helpful for us. With cookie 0, you can see that's the host VM, we have VM2. And now this is the proof that victim 1 connects to the user. And this is when it successfully connects. So we see that, yeah, before the attack it successfully connects. Now the user isn't able to connect. It just isn't able to connect. Hey, wait a second. Hey. Oh shit, man. I did something wrong. I just realized by looking at these images that I did a very bad thing. It shouldn't have happened. Ah, just a second. I should not have done that. Apologies on my end as well. So, what actually should happen is that first you do the sync flood attack and then you do the telnet command. We are trying to do that after the sync flood. So that is how it should go. I think I just missed that step and I directly tried doing it. So you can just go and you can just see the net. Getting a lot of sync flood, sync flood, sync flood, sync flood, sync flood. And then if you go and try to telnet, you won't be able to telnet. So that is the sync flood attack. I just started talking. I just mixed some part of that, connection loss to the foreign host, which is actually not a sync flood attack. It's actually TCP hijack. And the reversal part, I just got a little bit confused. Let's start talking about that. I'm really sorry about this. So this is the attack right here, and it is not able to connect. So that won't happen if the cookies are on. So the cookies are still 0, and you can see that. I mean, I'll show you what happens if the cookies are on. So the cookies are 1. You can see it here, right here. I mean, you can see it right here. The cookies are 1, and you'll see that it still connects. I mean, it is, yeah, it still connects. I mean, I'll just prove that connects to user 1 even after that. Yeah. So this will still happen if the cookies are 1. So that is the attack, and here it is, the TCP Syn Flood Attack. Thanks for being here with me till now, and I hope you got to know a lot about TCP Syn Flood, and you would want to know more about the hijacking, the reverse shell, etc. I'll keep posting videos about seed labs and doing stuff on this. I'd love to, and I'll do that. I'll be quite regular now, and yeah. So let's meet again sometime. Bye. Nuclear signing off.